Perfect. Now.
Okay, so this is typical of the type of training we have for sales partners. So we do this wherever we go, when we have meetings around the world or one-to-one meetings with sales partners. So we try to share as much information as we can. And I think the applications is always quite interesting. So this presentation has a collection of different applications that we've sort of presented over the years. So I'll go straight into it. So the presentation covers different markets. So one market is marine. That example is ballast water treatment. So I always say that in some countries you will not have that market. You won't have that opportunity. But it's still useful to know the capability of the product in different applications, because it may apply to an application you have. It might not be marine, for instance, but it may be relevant in another application. So it's always good to see the different types that we have. So marine, level measurement, some aerospace applications, heavy industry, laboratory. There's another aerospace example. Then test equipment. So this is test equipment for manufacturing or calibration. Industrial test process. Then some oil and gas, motorsport, hydrostatic level measurement. And then several examples of that. So we have some good examples for level measurement using a submersible transmitter. And then food. And then an interesting one is testing, but it's corrosion testing. So a mixture of different applications that will give you, hopefully, a better feel for the possibilities we have. So we start with the ballast water treatment. So this customer approached ESI, and they wanted to measure the pressure in ballast water treatment systems so that they can control the process. Now the background is that obviously ballast water in ships is used for stabilization of the ships, and as the ships travel around the world, they take on board water, seawater from one port, and they may discharge that water somewhere else in another part of the world. So the ships at different points, they take on board water when they're empty, and they discharge water when they're full of containers or oil, whatever. So the water has to be treated. It has to be cleaned, because if I had a ship now in Brazil, for instance, and I unloaded my cargo, then I would need to discharge water, and that water may have come from England, and it may contain microbes, plants, animals from London somewhere, and we don't want that. We have to make sure that the water inside the ballast tank is clean. So there's some pictures here showing the ship discharging water, and you can see the marine life coming out into the water, and then ticking water back on, and now the tank is full of microbes and fish and whatever from a different seaport. So this is a constant process, and there are laws now, international laws, that make sure that ships are fitted with ballast water treatment systems. So they must have very sophisticated systems for cleaning the seawater. And that uses a process that can be quite corrosive. So the organization is IMO, the International Maritime Organization. They have this convention, which came into place in 2019. The idea is that all ships must conform to this convention. So the process of cleaning the water is usually filtration followed by electrochlorination of the seawater. So the process generates a byproduct, sodium hypochlorite, in this electrochlorination process. So the water passes through these pipes, and there are tubes within the tube, and eventually the water is cleaned. This water is charged to kill the marine life or microbes inside, and the byproduct is sodium hypochlorite, and it's very aggressive. So usually these tubes are made from titanium, and you can see that most of the fittings are from a type of plastic, which I think is polypropylene. And this is because the seawater is corrosive with stainless steel and other metals, but also the byproduct of sodium hypochlorite is very aggressive. So you have to use materials that are compatible, and titanium and plastic is very good. So this is where our product, our GS 4200, and other products using silicon on sapphire. You remember last week we talked about silicon on sapphire, and it has a titanium pressure diaphragm that is welded to a titanium pressure port. So the liquid, the media, is only ever in contact with titanium. And this is perfect. It's not too expensive. It's quite a standard pressure transducer, but it has this excellent property of corrosion resistance. So the first application we had, the customer wanted to have this type. You'll be familiar with this, a thermocouple head. So it's a field accessible connection point where you can bring the cable through and easily connect the cable to the transmitter without any difficulty, with easy access, and then you can close the lid and it's weatherproof. So this is suitable for shipboard, outdoor use. And the customer was very specific. He wanted to have this aluminum head. And the product that was best suited to fit this head was the PR 3900. So normally this is an ATEX transmitter. It's usually for oil and gas, but it can be used anywhere. It has a very high IP protection, so it's suitable for outdoor use. Now, one of the requirements was that the product was marine approved. Now, we didn't have this 5 years ago, I think, when we started with this customer. We only had ATEX approval. And in this case, the customer accepted ATEX instead of marine, which is strange, but it was for the US Coast Guard. And the US Coast Guard said, if you don't have marine approval, then ATEX will be okay. So we supplied ATEX, but at the same time, we started the process of having DNV GL approval. So this is Veritas, a Norwegian approval, and Germanscher Lloyd is a combination, and it's throughout the world, really. Worldwide, it's an accepted standard. So you can see the DNV GL logo here. So this customer, other customers, were using GS 4200 and PR 9000 for this type of process. So we decided to have a group of products approved rather than just the PR 3900, which I will show you in a minute. But these are possible applications for marine approved transmitters, but not just marine approved, but for all applications really. So we have diesel engines, drives, compressors and pumps and boilers, hydraulic and pneumatic systems on board ships, fuel and storage systems on ships, and also reverse osmosis, where seawater is converted into fresh water. So the core sensor that we have, which is titanium, is perfect for all these applications.
Okay, sorry, I have a question about the in the first application. Who is the specific profile client? I mean, is the manufacturer for the biofiltration plant, or is the manufacturer for the ship, or really is the company that logistic that later buy? I ask this because in our case we have just one manufacturer in Cartagena. It's a public and private company, have a mix here, but the other ones is just for logistics. So for this reason, I think that we don't have companies that manufacture biofiltration plant. I think no. We need to check or research more the market about that.
Yeah, you're right. The majority of our customers are companies who make systems for ships. So at the moment we have manufacturers in Germany, in Norway, in the UK, and these companies, they actually manufacture the filtration systems. So they are filtration companies. They have contracts directly with shipbuilders, companies who install equipment onto ships. So it's shipping companies, but also shipping subcontractors who do the installation. But mostly we supply the manufacturers. But occasionally we do get requirements from the ship manufacturers or from service and maintenance companies, so companies who specialize in providing components for the sea, for ship use. Perfect. So occasionally we get a company in the south of England will call and say they have a vessel docking soon and they need transmitters for some seawater system, for hydraulic system. Okay. But normally they will ask for marine approval. Do you have any products that are marine approved? Yeah. So this now we have we can say with total confidence that our products are verified for marine use. Okay. I think we have a. Sorry that today I am in home, so for this reason you see look at my creation to my kids
in the class. So for this reason, sorry that I hadn't come. Look at, for example, in this case, my new office today with my child.
Okay, actually, your video is not. Oh yeah, there you are.
Yeah, look at. So for this reason, sorry that I hadn't come. And look at this creativity week that had my child. So for this reason, sorry this I off my video.
Your video is just gone again. You came back for a little while then.
Yeah.
Yeah. So So you have your children's.
Yeah. I have no, because here I don't have in my home. Unfortunately, the place in your home for study converts to childs for have the old toys, and so for the reason I stopped my video. Yeah.
It's okay. Yeah.
Okay.
So yeah, your video keeps coming and going. So
yeah.
While we're on the subject of marine, I'm just going to try to open up another presentation very briefly. Oh, please bear with me because there's another presentation I need to show you quickly.
In Panama, do you have a partner?
In Panama?
Yeah.
Yeah, I imagine. Sorry, I can't find this presentation. Marine. There is a presentation that is just about marine products. Not sure where that is. Or maybe I'll come back to that. But there is a nice presentation that shows the full range that we have. Yeah, I'll just very quickly show you this. This is a presentation that we made just for marine applications, and it explains a little bit about the approval process. Okay, so if you can see that page,
yeah,
it has the classifications for use on ships, and you have temperature, humidity, vibration, EMC, and enclosure rating. So you can see you have machinery spaces, control room, bridge, pump room, and open deck. So open deck is one of the most difficult classifications because of the exposure to the weather. I think this. So this explains what classifications we went for. So for temperature, we went for class D, which is the most difficult. Humidity, we went for class B, which is also the most difficult. And enclosure, we went for C and D. So D is completely submerged. So there has to be a PR3400 series submersible transmitter. But everything else is to enclosure level C. And then for vibration, we went for B, which covers most of the ship, everything apart from the mast. Well, you won't find a pressure transmitter up a mast. So, and then EMC, we went for the highest rating on immunity and emissions. And this is the product range. So these are all standard products, but every one is available with a marine certificate. So we have very low pressure. Then we have, with the GS4 200, we have the low to high. And then for HP series, we have very high pressure. So we can cover from 0.1 bar to 5,000 bars. So we can cover any pressure range on the ship. And then we have the PR3900, which is the one I showed you before with the aluminium head, and then the submersible for level measurement. So with these 5 products, we have a very broad coverage of applications on board a ship. So I wanted to show you that so that you could get an idea that if you have an application on a ship that needs approval, then we have quite a wide product range. We can cover lots of different pressure ranges, variations, different output voltages, connectors. It's quite open, really. Okay.
Okay.
So back to applications. Yeah, so that's marine. But you can see, I mentioned last week about the SOS sensor. Real benefit of that sensor, because it's made in titanium. So anywhere on a ship is going to be ideal. Even if it's been splashed with seawater, it won't corrode. So then we have level measurement for diesel applications. So this is slightly unusual, but you can see these tanks. They are generators, and inside is a generator, and every generator has a diesel fuel tank. Now this customer, which is actually Caterpillar, they were using a resistive probe. So if you can imagine a probe that goes into the tank and goes all the way to the bottom. So the tank may be 2 meters, 2.5 meters deep. So the probe would be 2 meters long. And it was a resistive device. So as the tank fills up, the resistance changes. And the change in resistance can be equated to a level. So they could tell whether it was 5%, 10%, 50%. They could quite accurately measure the level or interpret the level inside a tank. The problem is that the generators are housed into these containers, and once they're inside the containers, it's very difficult to change the sensor if it fails or if it needs calibration or maintenance, because there is no height. There's only a very limited space above the tank. So really, the generator needs to come out of the container just to change the transmitter or the sensor. So we were asked if we could make a sensor with a cable that could be dropped into the tank through the small space, and but still give a resistive output. So you'll see what I mean when you see the next slide. So we took the standard PR3441, this is our submersible transmitter, so it's made from stainless steel. It has a polyurethane cable, so it's suitable for diesel. And this is a molding, this is a polyurethane molding, which gives the connector strength and makes a seal between the cable and the transmitter. Now inside here, we also have a second seal. This is an O-ring seal that is clamped. So you can't see it because it's buried under the molding, but effectively we have two seals against the outside world. So normally this would be typically 4 to 20 milliamp. And what the customer wanted here was a special housing that could be fitted to the top of the tank. So the transmitter would have a cable, in this case I think about 2 meters long, and the cable feeds into this housing. We call it a bell housing. So inside here we have electronics and cable connection, but also inside the pressure transmitter we have a temperature sensor as well. So you can see it has two outputs, one connected for temperature, one for level. So this gives a 4 to 20 milliamp output from the pressure sensor, and this one gives a resistive output for temperature. Now, later on in this presentation, there's a little bit more about level, so I can explain a bit more about the process. But you can see here from the photograph that we have the transmitter with the cable, this flange, and two connectors. So what this customer wanted, because they were retrofitting a resistive output sensors, they wanted the transmitter to have a resistive output. So when the tank is empty, the resistance will be 250 ohms, and when the tank is full, it'll be 32 ohms. So this is just replacing the resistive probe. So converting our 4 to 20 milliamp output into a resistive output. So there is a special circuit inside this housing that makes that conversion. Right, so that is
sorry,
quite unusual.
I have a question. This magnet is for the wall inside the tank.
Yeah.
Okay.
Yeah, sorry, I forgot the magnet. Yeah, because the generators are transported, the tank will move around.
Yeah, exactly.
Uphill and downhill. So the customer asked if we had any ideas of how to ensure that the transmitter would always be on the bottom of the tank, and also that it wouldn't move around. So we have a small but powerful magnet on the side of the transmitter. So when you lower the transmitter into the tank, you can hear it snap into place.
Yeah.
Neodymium magnet. So it's a high-powered magnet.
But the magnet is just in the side or in the bottom. I mean for the measurements. The measurement is bottom, no?
It's the bottom. It's the bottom. So
okay.
It's quite a big tank. So when it hits the bottom, it will stay in that position.
Okay.
Quite thick, actually. It's quite strong magnets. Once it hits the bottom, it will stay in the center, and it will not move around, not easily. It's quite a strong, quite strong, powerful magnets. Quite interesting, really.
Yeah.
Yeah. Neodymium magnets. Okay. They are crazy powerful, really are.
Yeah. Well.
But not too powerful, because then you can pull them out. So next application.
I'm sorry, I have one question.
Sure.
But in this case, if we use the magnetic, we are not just like having a limit with the material of the, I don't know, maybe a tank. If it's using a material made of plastic, this couldn't be a problem?
Yeah.
No, we would have to find a different way to do that. Sometimes you can fit brackets into the tank the difficulty with this application is that the access to the top of the tank was very limited. I think maybe 400 millimeters. So it's very difficult to actually fix anything into the tank without removing it completely. But in other applications, there are ways of fixing the transducer into a position. We can use tubes. We can use brackets. Different ways. Each one would have to be evaluated. Really, we'd have to understand the application and make recommendations. But there are, as you can see, there are lots of things we can do to make variations of the submersible product. We do quite a few different types overall. Okay, there is a section later in the presentation about this product as well, so maybe we'll look at that. So this one is, I'll just go through this one quite quickly. So this was a big aerospace manufacturer, and what they do, they make the structure of the aircraft, build the aircraft, add the hydraulic and pneumatic systems, and then they test the functionality of all of those systems, whether it's pneumatic, hydraulic, flight control, landing gear. So lots of different pressure ranges, and they need, the tests need to be very accurate. They need to have a high level of accuracy, but most importantly, a high level of reliability, because when they run the tests, they can last for many, many days, where the pressure systems are constantly pressurized and reduced and pressurized, lots of cycling going on, and sometimes some quite dynamic pressures, sort of shock pressures, to test the systems, to test the structure. And this application needed 300 pressure transmitters with a high level of accuracy, and importantly, a high level of resilience to pressure cycling. And that is perfect for our silicon on sapphire. So there's reliability. The accuracy level was needed to be 0.15 non-linearity hysteresis. So they needed a high level of accuracy that was reliable. And the pressure ranges were from 200 psi, so around about 15 bar, up to 6,000 psi, 400 bar. And they needed, of course, a special aerospace connection, 7/16 thread, and a wide temperature range. So the testing of these structures would be, certain areas would be subjected to quite wide temperature changes. All part of the verifications of the process of the tests. And it needed, as it was for America, of course, it needed a military type connector. Now, the other challenge, apart from reliability and accuracy and resistance to overpressure and cycling, they also, at the very last minute, asked if we could fit a TEDS circuit. They may or may not have heard of this, transducer electronic data sheet. And this system is used in lots of different industries, aerospace for sure, but also oil and gas, and some other process industries. And the principle is that the transmitter is fitted with an EEPROM. And that EEPROM can be loaded with data. So you can put the serial number of the transducer, the output sensitivity, calibration data, pressure data, calibrated pressure records from the manufacturer. So at different pressure levels, at different temperatures, you can put all this data onto the EEPROM. And it's all done to a international standard, 1451.4. And it was a little bit of a challenge, but actually ultimately not too difficult, because we just needed to locate an EEPROM that conformed to this standard. It also had a very high output. If you remember last week, I mentioned that silicon and sapphire sensors typically have an output of 10 millivolts per volt, but actually it can be as high as 20 millivolts per volt. So this customer asked for the highest possible output that we could achieve for all ranges. And so we guaranteed that each transmitter would have an output of 14.5 millivolts per volt. So that's actually, with a 10 volt DC supply, that is an output of 145 millivolts. So very high sensitivity. And it's perfect for their data acquisition system. So this is what it looked like. In reality, it is one of our HI 2000s. It's an HI 2000 pressure sensor. So millivolt output, small housing with a military connector and aerospace fitting. But inside, it has this EEPROM. So you can see the connection details are printed on the side. These are laser marked, and you can see that it's 6 pins. So pin E and pin F are the TEDS communication. So one is TEDS in, one is TEDS out. Now, the customer has a data acquisition system that works to that standard. It works to the TEDS standard. So they wanted the transmitter supplied with no data. The EEPROM was left completely blank, no information on the EEPROM. And when they received the units, every unit they received, they put through their own calibration process. So they use their own high accuracy calibration equipment and systems, and they made their own calibration records. They wanted our calibration records, but they would work to their own. So they loaded the transmitters with data from their own calibration. So pressurization up and pressurization down, lots of information. And that means that they can carry out a test on the aircraft structure, and then maybe in 3 months or 6 months' time, they can bring the transmitter back to the test lab, and they can compare the current calibration after testing with the original, and they can calculate the change, if there's been any change. And it helps them to verify that the tests they've carried out were accurate. So a really, really interesting application. But it's worth knowing about these applications because in this case, the customer has now had the product for at least 2 years, maybe 3 years, and everything is working perfect. They were buying an American brand beforehand. You may know it, called Q-Lite. Famous American company who make aerospace transmitters, but they were not happy with the performance. And our product, thankfully, was far better performance than Q-Lite. So again, this is silicon on sapphire sensor technology. So the pressure port is titanium, and the rest of the housing is stainless steel. And it's a big success story. Now, TEDS may not be required everywhere, but it does give you an idea of the sort of customization we can do. And it doesn't have to be 300 pieces. We can make 2, 3, 4, 5, 10. We are happy to make specialized units for even small requirements. And that's one of our specialities. It's that ability to customize to suit the application perfectly. So I think that's quite interesting.
Yeah. In our case, this market is just for research, but
Yeah. Yeah, could be research. Anywhere that carries out intense research, they want to put the system through high temperatures, high pressures, dynamic pressures. It's that little bit of customization can make a big difference. And we regularly make 1, maybe 2 pieces, or 10 or 20. It doesn't have to be 100 or 300. It can be any number. If it's something we can do, we will offer it. This one is actually for standard products. So this is a good example of where a standard product has been really successful. So it's in bolt tensioning systems. So this is a method of tightening bolts. So it could be in a chemical plant, it could be on an oil and gas rig, it could be in a factory, wherever you need to make a secure connection between 2 flanges that connect pipework. To ensure a good seal, you have to apply the right level of torque to the nut. And more systems now, or customers, require that there is traceability. They want some kind of digital traceability, that the bolts have been tightened to the correct level. I'll give you an example that I had recently. Was for wind farms, for wind power generation. A lot of the masts that the windmills sit on are bolted together. And there have been cases where the tightening of the bolt has not been uniform. And in fact, some of the towers have collapsed. So there's a drive to improve the accuracy and the reliability of bolt tensioning. So there are several manufacturers who make this type of device that guarantees that the right torque is applied, and that is then recorded to a system for verification. So this is an example. This is one of our customers. So the hydraulic pressure is injected into this clamp, and it forces this piston here, this piston ring, if you like. It pushes upwards, causing the bolt itself to stretch. So rather than use a big wrench or a big spanner to tighten the nut, what happens here is the nut stays in place, but the bolt is stretched. So the collar screws onto the end of the bolt. Hydraulic pressure, really high hydraulic pressure, is applied, and the collet pushes upwards causing the bolt to stretch. And when the bolt is stretched to the right amount, the nut is tightened, so there is no friction. So our solution for this is the USB transmitter, because you can use it to measure the hydraulic pressure very accurately, but at the same time, the information is being recorded to the laptop or the PC. So in this example here, you can see 1, 2, 3, 4, 5, 6, maybe more tensioning devices on the top and on the bottom. And all of these are connected to a USB transducer. And simultaneously, they are connected to a PC, and the data is recorded all at the same time. So as the bolts are stretched upwards, the pressure is recorded. They then know that the right pressure has been applied, and then there's a simple tightening method. I think I have I don't have a example there, but if you can imagine going back to this slide, that once the bolt is stretched, you can see here, there's a little hole by the 5, there's a little hole here, and you put a little dowling in, a little metal bar, and you move it to that position, just a quarter of a turn. So the nut is screwed onto the bolt until it meets the surface, but at this point we don't tighten it. Then we stretch the bolt upwards, so the nut then moves away from the surface, and simply turn it to this position and then release the pressure. So what you have is a tensioning of the bolt and the perfect tightening of the nut without any friction, and that guarantees that the two components, the two flanges, come together with even torque at the same time. So quite an interesting one, really. But the USB is absolutely perfect for this type of application. Anything where you need to apply pressure, especially if you need to apply pressure, maybe 2 or 3, 4, up to 16 pressures at once, you can record all of those events simultaneously.
Okay.
This one is a manufacturer in Denmark. A test house in Denmark. They do make machines. They make machines for calculating the shelf life of food and pharmaceuticals. So in this case, I have peanuts as an example, and the equipment that this customer manufactures, it determines the oxidative resistance of oil and fat in raw materials. So as you expose the food to oxygen, it will start to degrade. The oils will leave the product and they'll start to become dry, and eventually they will start to deteriorate. So it's a method of accelerating this deterioration in a controlled way. So in a short space of time, you can determine what the shelf life is for products like foodstuffs and pharmaceuticals, cosmetics as well. So our customer puts the foodstuff into a chamber, and they introduce oxygen pressure at 5 bar pressure, and then they heat the chamber to accelerate the aging process. And what happens is the oxygen is consumed. It is consumed by the product, and that means that there's a pressure drop. And they can calculate what that pressure drop means in terms of aging. So it's a scientific type product, but they need to measure very small drops in pressure as the oxygen is consumed. And that rate of oxygen consumption can be used to calculate the shelf life. Very, very clever.
Sorry, Paul. Do you have a picture for a pressure chamber or for this process? Because I really
this is the equipment.
Okay.
So you can see at the top here, these are GS 4200 transmitters. You'll notice straight away that they have the small DIN connector. So this was a requirement. So we needed to convert from the larger DIN socket to the smaller one. And also you notice that the housing is very small. They wanted the unit to be as small as possible. And this has a millivolt output. So their electronics, their little box of tricks here, it takes a millivolt input. And it was very, very specific millivolts. It was actually 4.7 millivolts per volt. Very strange, but when they originally developed the product, their product, they were buying a transmitter from another company, and they were using the maximum output. So one of the conditions that we had to meet was to have this strange output. So normally, the full-scale output would be 100 millivolts, but they needed 47 millivolts. So again, it's a customization. It's very easy for us to do that. We just fit a resistor network to the sensor, and we reduce the output. Most people want the highest possible output. This customer wanted a specific output. And he uses several 100 to 200 per year for this application. It's silicon on sapphire again. It's very accurate. Gives the level of accuracy they need, and it's also very stable at high temperatures. So sometimes this can be 120, 125 degrees C. So it's very comfortable. It works very well. But actually, for us, this is quite a standard transducer. GS4201, 10 bar, short housing, small DIN connector. It's a customized solution, but it's a very easy customization. But the customer gets exactly what he wants. He has a high output, good temperature resistance, very accurate. So in this area here, behind the front is a stainless steel chamber.
Okay.
This is where I have so many presentations. Some presentations have extra bits, but if you can imagine, like the small size of a large teacup, a mug of tea, that sort of size, and you can put sample materials in, close it, seal it, and then inject through this spigot here. You can inject the oxygen, and the data is recorded, and it will calculate the shelf life. Okay, so this application is a little bit too specific, really, because it's for a a fighter aircraft for use on the fuel system. But this is just an example, really. I wouldn't worry about the aerospace aspect. It's just an example of the sort of customization that we can do. So we take a fairly standard product and then make changes. So this one has a military connector, high temperature cable, pressure range of 180 psi. So it's very easy for us to make in between pressure ranges. It doesn't have to be a standard pressure range. It has a millivolt output and a special connector. As you'll see, it's a swivel connector. So it is not a fixed thread. It has a thread here, but this nut rotates. I think there's a photograph. So you get an idea. So it's aerospace, so obviously the silicon on sapphire is a good solution. And we weld a sort of spigot to the transmitter. So the transmitter, the sensor doesn't have a thread as such. We weld a small piece of titanium and then use this aerospace nut. So that rotates, so there's no twisting of the transducer. And again, a small housing. So it's a rotating nut. And it has little features. It has, because it's quite low pressure, it's inside an aircraft, so the altitude changes rapidly. So the outside air pressure is always changing. And because it's a gauge reference relative to atmosphere, then the housing must be vented. So the housing has a special filter which allows air to pass in both directions, but it does not allow liquids, only air. So that's quite an interesting product. Now this is a market that we supply very, very widely. There are lots of manufacturers around the world of test benches. So lots of countries have companies who make their own test benches for all sorts of applications, for testing valves, ball valves, different types of on-off taps, that sort of thing. Make sure that they close properly. And they build these units to be able to attach the valves and pressurize them. And quite often they'll have pressure gauges, but now, more often, they will also have electronic connections as well, so that they can record the data. So you may see, just about make out here, there's a digital panel meter here, and that will be wired up to a pressure sensor somewhere. So usually this system will have a pressure generator, quite often high pressure, but it can be any pressure, and that will generate the pressure to make the test. And you'll be able to see visually on a panel meter the pressure applied, and using different types of panel meters that you can then connect to a computer system or a data acquisition system.
This is the most often application that we have in Colombia, for example.
Oh, right, yeah. Yeah. I think around the world there are a lot of people who make these types of equipment for the local market. And yeah, you just need a pressure generator, and then it's pipe work and transmitters. Now, I think in the marketplace, we found a lot of these people are specifying ESI products. And it's because of the design of the sensor that I mentioned last week. So for certain pressure ranges, we have this welded titanium sensor. So there is very little risk of any leakage. The welded sensor is a very secure device, but the titanium diaphragm is very, very resistant to pressure spikes. So quite often in tests like this, you'll have perhaps a sharp rise in pressure, or alternatively, a sudden drop in pressure. If you were doing hose testing and the hose bursts, you get a very quick drop in pressure, and increases and decreases, sudden increases, decreases can damage pressure sensors. And because of the robust structure and the titanium, it's very difficult to damage an ESI sensor this way. And gradually, partly through our marketing and our contacts, but a lot of this has been word of mouth. People look at this equipment and say, "Hey, I wonder what transmitters they use," and they say, "Oh, who is ESI?" And they do some research, and suddenly we get inquiries from around the world asking for transmitters for exactly this application. So at the moment, we have lots of customers in the UK for people making various types of test bench. We also have a lot in the US, but also Germany, in the Middle East, in Asia, China, Singapore, Thailand. There are manufacturers all over the world making various types of pressure test equipment. And we are finding more and more that people are using our product. And that product will usually be GS 4200. For the high pressures will be HI 2000, sorry, HP 1000. And of course, the USB. The USB is perfect because you don't need panel meters, you don't need displays, you don't need data acquisition systems. You just need a laptop or even a tablet or an industrial PC that you can build in. So these are the products I just mentioned. This one is made in the Netherlands. So this company use our products a lot. It isn't a very good photograph, but inside there's a pressure generator, and the stainless steel pipework that moves the pressure will have a GS 4200 or an HP 1000 or a USB transmitter. So it gives the level of accuracy that people want. In Scotland, I had a customer who had a very similar product for the oil and gas industry, and he wanted to have an accuracy of 0.1%. So we said, okay, in that case, you need to pay a little bit more money, and we'll supply you with the high accuracy option, GS 4200. And sometimes he would buy the standard version, sometimes he would buy the high accuracy version. And what he realized is that the standard version quite often was giving the accuracy that he wanted. They were already performing at 0.1%. I think I mentioned it last week, that when we say in our data sheets 0.25%, that is absolutely the worst possibility. 90% of every GS 4200 or HP 1000 that we make, in reality, you'll find that it's closer to 0.1% accuracy. That's why we never have complaints about accuracy. So here's one. This is manufactured in Germany and in the Middle East. And this photograph was taken at an exhibition in Abu Dhabi in the United Arab Emirates. And I walked past and I said, oh, this is nice, pressure generator. And you can see here, this is a computer. It's a integrated screen with a processor. So all the electronics go back into the PC. So it's also a data logger. It's quite a powerful little device. So it's quite compact, quite simple. It generates very high pressure. I think it generates to 2,000 bar, and it's a very simple pipework inside. But when I mentioned I was from ESI, he said, please come round the back. And he pointed out that here you can see the USB transducer. So he was already using an ESI product, and that is just simply wired to the PC. There's a protective cover to protect the screen, and it provides the power to the transducer. So every test or every function of this unit has a display, but also it has a data logger. It records everything that happens. So when you apply pressure, it will record that pressure and the results of the test. So quite interesting. So the test benches can take all sorts of different, all different sort of shapes and sizes. And one of our customers in America put it into a Peli case with a screen, a tablet, and they use it as a portable data recorder to replace the old-fashioned chart recorder. And this customer in Norway, they integrated into a case with a laptop, and they have usually 2 or 3 pressure transducers, different pressure ranges, so that whoever has this equipment can test low pressures, medium, and high pressure, just with the one case. And in fact, most of their business is rental. So they put these kits together and they rent out this as a portable test lab. So interesting ideas for the GS42, the USB transmitter. Yeah.
I imagine that this tablet it just works with Windows system, no?
With adapters.
The tablet with just works with Windows system operation.
Oh, Windows, yeah. You can make it work with other systems. John is our expert for that, but yeah, Windows is the number one, really. Yeah.
Okay.
So in this case, I know I have a guy in Egypt who does the same sort of thing, and he has a box of adapters. So he has G quarter-inch BSP as a standard fitting, but he has a little box of adapters so that he can connect to any pipeline, any system. So you'll have NPT, BSP, metric threads, so we can just screw on an adapter and carry out a test anywhere. So people are quite inventive, actually. So the next product, yeah, this one is a bit specialist. So obviously, when we're drilling for oil, when we're looking for oil, or when we find oil and we want to measure the volume of oil in the well, there's all sorts of tools available that are deployed deep under the ground. Some
Adrián, ¿usted está ahí?
we've been trying to get into for a long time.
Se cayó.
Yes, Paul. More or less, in when you began to the download and press login, the connection is stopped. Exactly.
Oh, okay. Yeah, no problem.
Okay.
I'll start again. So,
Okay.
so yeah. So when we're exploring for oil, you have the drilling process, and it's important to measure the pressure when drilling. So obviously you drill, you pump out mud. As you drill deeper, you have to remove the earth and the rocks, and so you need to measure the pressure, keep the pressure stable while drilling. And also, when you've completed the drilling and you've managed to hit the oil reserve, then the tool will quite often remain in the hole, and it will communicate back information about temperature, humidity, porosity, but also pressure. So temperature and pressure are really important, and they can calculate the volume of oil in the well by drilling one or two holes and comparing the pressure readings at different points. And they can calculate quite accurately the volume of the oil. They can also monitor the pressure. If pressure in the oil well deteriorates over a period of time, that suggests there may be a leak, or you're losing your oil reserves. So it's really important to measure pressure in these downhole applications. But the conditions are really bad. They're usually very, very high temperature. So we have made a sensor, a transmitter, a very small transmitter that will work at 200 degrees C. It's completely sealed, and you would screw this into the tool and connect to special high temperature circuit boards, and then that can be communicated to the surface, or it can be attached to a data logger in the tool that can be extracted in a few months' time, in a year's time, sometimes 5 years' time. But the conditions are pretty bad, so there's all sorts of nasty chemicals down there, acid-based. So titanium is good for that, and the high temperature is also a problem, and also high pressure. So it's altogether a very difficult environment. So this product is just 57 millimeters long and only 12 millimeters in diameter. So it's very small, but it's very, very robust. And this is the typical of the type of sensor or transducer that companies who are involved with making drilling tools, this is the type of product they use. So we're trying to break into that market. We've had this product for more than 2 years now. We have a lot of companies, big companies, testing the sensor, and so far it's going well. They like the product, but we're still waiting for the big order. But it also has a temperature sensor, a PT1000 on board, and the output from the temperature sensor can be used to make what we call polynomial corrections. So it's a long, complicated polynomial which you have to key into your logging system. But ultimately, what it means is that the output is very, very stable, no matter what the temperature is.
Otra vez se le cayó.
La señal se volvió a ir.
Sí.
No.
Yeah, did I lose you again?
Yeah.
Ah,
Yeah, no. But it just in the last 30 seconds when you comment to the polynomial correction. Just
yes. So that's the complicated formula, but we provide data that you can key into your equipment to make that correction. What it means is a very stable output, stable reading, very, very accurate. And yeah, it's completely sealed. And we've been trying for 2 years now. We've got samples everywhere with some big manufacturers, and the results are really good. So we're just waiting for the big orders now. But it's a very specialist product. But there are only really 2 or 3 competitors in this market.
Okay, just a question. Okay, we know about the linearization correction, but I never before listened this polynomial correction. In terms for accuracy, what is the difference really with this compensation or correction?
Yeah, what it does is as you have temperature swings, the temperature's forever changing. It means that the output stays very stable, so that when you read the pressure, it doesn't move around a lot. It stays very consistent, and that for the oil companies that's really important, because if the well temperature changes for some reason, it could mean the difference between several thousand barrels of oil. And potential loss of value. So stability is the big thing. Repeatability is big as well. They need they cannot have drift. The sensor has to be stable. It's a real challenge, but we've got really good feedback. Some of our customers have given us reports that suggest that it's performs as well as any other sensor. But we're just waiting now. We're just waiting for the first big order, really.
Okay.
So it's a little bit slow. It's specialist, but it's a good product. We know it's a good product. Okay, there's a typical drilling tool. So it would be somewhere inside here. Wellhead control. Right. This is. So this is a system where the tools with the downhole sensor. So these are examples of downhole logging tools. So in here you'll have all sorts of sensors, pressure, temperature, all sorts, angle, accelerometers, everything. And this information is stored on a high temperature data logger, and that information can be extracted either by communication through wireline or by retracting the tool, bringing the tool back to the surface to analyze it. But in order to deploy the tool, to lower the tool into the well, this special wireline cable is used. So it's a very strong cable, and it's also a communication cable. And the cable passes through the blowout preventers that lead to the well. So the wire passes through this system here, and in order to make a seal, because the cable must be allowed to move through this system, and to make a seal, high pressure grease is injected around the outside.
Okay. Se le está yendo mucho.
Sí, la carga.
Will be fed down into the well, and the wire needs to move freely up and down. Again. Are you still there?
Yeah. It's because I think that in 30 seconds, no more or less, we lost you, but
okay.
We're
yeah. So the wire must move freely up and down the cable, and I think the next one, no, it doesn't show you here, but this skid has several of our pressure transducers. So it provides the wire that goes to the well, and it also provides the high pressure pump that delivers the high pressure grease. So on here we have several of our high pressure transmitters, 400 bar, 1,500 bar, and they measure and control the pressure of grease into the wire line. And the whole thing is placed onto the back of the truck, and it's completely portable. So the whole truck is certified for ATEX environments. So obviously our transmitters are ATEX approved, so they're intrinsically safe. But in actual fact, the whole truck is intrinsically safe, believe it or not. So you can drive out to the oil well, lower the measurement tool into the well, and the grease is injected around the outside of the cable, so it makes a seal, but it also allows the cable to move. So this is a customer in the UK that make these systems. Basically, they make this skid here. This one was our first application for the dynamic USB dynamic. So the dynamic USB will measure 1,000 readings per second. So it's very fast. And this company in New Zealand were making systems, or suspension systems, shock absorbers we call them. Not sure what you call them. I know in America they call them something else, dampers. But these are shock absorbers that you can preset. So they're for racing cars, and you can set them to a hard ride or a soft ride. And they fitted the USB transmitter to the car, then drove around, making adjustments to the shock absorbers each time, using the data collected from the USB transmitter to make a decision on what the best setting is. So they could see what sort of dynamic shocks they were getting as they were driving around, and they could adjust their suspension to make the car as fast as possible on that track. So that's a fun example, I think, that one. Now, a little bit about hydrostatic level. So this is a submersible transmitter, and the sensing diaphragm, the sensing element, is always at the very front of the transmitter, just behind the cone. And it will measure the liquid column, the weight of water, hydrostatic pressure. So when the tank is empty, the output will be zero. It will be 4 milliamp if it's a 4 to 20 milliamp transmitter, which mostly it is. And then when the tank is full, it will be 20 milliamp. So we will calibrate the unit to suit the tank. So if it's 0 to 5 meters, 0 to 10 meters, or 0 to 8, whatever, we can set the transmitter to read 4 to 20 milliamp over that full scale range. And the power is delivered through the cable, obviously, and the signal comes back out through the cable. So this is an important factor. Of course, you want to measure the column of liquid. You want to measure this distance of liquid. But the liquid is under atmospheric pressure. So the sensor and the surface of the liquid must be in balance. Otherwise, you get unreliable readings. So this means that the sensor must be open to atmospheric pressure. So we do that by having a vent tube running through to the sensor, meaning that the atmospheric pressure is acting on the surface of the water and the inside of the pressure diaphragm at the same time. And if this is the case, then the reading from the sensor will always be true, give you a true reading of the liquid level. So it doesn't matter whether you're on top of a high mountain or a sea level, you will always get an accurate reading of liquid level. And that's important because in some tanks, you may have a sealed tank where you have some pressure on top of the liquid. Maybe on a hot day, the air expands and presses down on the liquid, and then you won't get an accurate reading. So venting is really important. So it's compensation really for atmospheric chambers, for that atmospheric pressure. So you can see this is the vent tube. So this is a nylon tube with a very small hole, but it means that the air pressure here is also acting on the pressure diaphragm. So some applications, many applications, storage tanks, process tanks, boreholes, rivers, reservoirs, lakes, I guess, as well. Anywhere where there's liquid, you need to measure accurately. So as you saw before, if the tank is empty, if we talk about 4 to 20 milliamp, it could be 0 to 10 volts or 0 to 5 volts. The most common is current output, 4 to 20 milliamp. So when the transmitter is reading 12 milliamp, it means that it's half full, 50% full. So this is our standard unit. It's easy to use because you don't need to fix it to a tank. You don't need to make any holes in a tank. You just need access from the top, and you just lower it down to the bottom, and immediately you'll get an accurate measurement of level. So 4 milliamps empty, 12 milliamps full. So here's an application, typical application, where the transmitter is sitting at the bottom of the tank and is giving a signal to the control box here. And from there, in this example, the panel meter or the display is providing the power that goes to the transducer. Then the 4 to 20 milliamp signal comes back and goes back to the panel meter to give a display. And this display has an alarm system, in this case, sound and vision, and also has connection to GSM. So that's just a simple example about how easy it is to use a submersible transmitter for level measurement. No need to make any modifications to the tank. That's a big thing. So in this case, we have panel meter, alarm, modem, data logger. You can connect to all these controls. Excuse me. We also have the terminal box. We have this add-on accessory, which is a desiccant box.
Mm-hmm.
So if the transmitter is used in an area where there's a lot of humidity, what can happen is that the nylon vent tube can actually pass moisture to the sensor, and we don't want that because the sensor will potentially short circuit. So in areas where there's a lot of moisture or steam, perhaps, we can use this device, which allows the transmitter to breathe, but the air passes through desiccants and the moisture is removed to protect the sensor. So that's an accessory that we have. So this is an alternative measure of level measurement. This is a dairy or a milk storage facility, milk production, and large volumes of water are used in the processing of milk. Same with wine, same with a lot of foodstuffs. You always need a lot of water. And quite often the dairy in Manchester near to ESI, they have 10-meter tall storage tanks with thousands of litres of water. And what they didn't want to do, they didn't want to put a hole in the side of the tank. So the pressure measurement range they required was 8 meters water gauge with 120 meters of cable. So this means that they run the cable up the side of the tank to the top and then down into the tank and actually across to a control center where they can monitor the level of water. So they need to make sure that there's plenty of water available at all times. So the tanks must almost always be full. So as they empty, the signal from the transducer is used to trigger a pump that will switch to a pump that will refill the tank. And then when it reaches 8 meters, to prevent the tank overflowing, the software will control the pump and turn it off again. So it constantly filling and emptying and refilling, emptying and refilling. But using the control software, you can set the low level and the high level so that it doesn't overflow and that you you never go too low. So you may set the low level at 2 meters, 1.5 meters, and then the pump will automatically start to refill.
Yeah.
So the process is never broken.
I have a question about the material for the cable, because in the past when we offered this equipment for the milk application, the clients comments about the certification 3CLAM or 3A or something like that about the cable. In this case, we have problem with that, because the housing, we know that we don't have problem.
It's a good question. It's a very good question. We are in the process of re-evaluating the product range, and we know that we need a hygienic cable.
Mm-hmm.
So we're looking at modifying the back end here, where the molding is on this one. We're looking at having a different system so that we can use FEP cable, which is a good cable for food and also for chemicals as well. So we're hoping that in 2021 that we'll have an alternative cable. But 3A is also something that we are striding towards as well. That's a separate issue, but we are looking to have approval for hygienic use as well.
Okay.
So we'll keep you informed about that. At the moment, we only have polyurethane, so it's okay in water, but maybe some food stuff is not suitable.
Okay.
This is an application that we supply quite a lot to, is fuel tanks, diesel storage. So we have a customer who makes systems for monitoring, remote monitoring of storage tanks. So these storage tanks, for instance, are all over the UK, sometimes underground, sometimes in storage facilities, military, government, that sort of thing. And they make a system that measures the level and contents of a tank, and that can be communicated wirelessly or by some SCADA system to a central location, so that it's security really, that the owners can keep a very close watch to make sure that the diesel is not being stolen or used inappropriately. So very nice system that they manufacture. And right, I thought I had a photograph. I don't have a photograph of that picture. It's a little unit that fits onto a tank or a sort of a filling station, and when there is delivery of diesel, or where there is a vehicle taking diesel, they have a key card and they have to sign in before they deliver or take that fuel, and that is all recorded and available in a central network. So there's real-time monitoring of who is taking the diesel, what time, and where it's going. So it's quite a nice system, that one. We do a lot of diesel storage tanks. This is an example of a river or lake, if you like, where you have sediment on the bottom. It could be anywhere really, but quite often when the transmitter is lowered to the bottom of let's say the river in this case, the nose cone may go into the sludge or the mud at the bottom. And if the sensor becomes blocked, it will stop reading. So the water level could reduce and the sensor won't react. So where we have applications like that, we offer this sludge platform version, so that the transmitter is always above the mud level, so it doesn't become blocked. So quite an easy one to understand, and that's a typical sort of application. And then where you have dynamic level, so you may have a river where the water is uneven, or maybe even a tank where water is being agitated. So in order to measure a true level you need to have an average, or have some way of making the water level stable. So you can do this with a stilling tube. So lots of different types available. So you place this, you fix this into the water or the liquid, and then lower the transmitter into the tube. So the tube will always be full of water, but of course it will be stable between these 2 points. So it sort of averages out the effects of the water moving. So that's another sort of accessory that we have.
We can offer this stilling tube.
Sorry.
We in our list, product list, we have this stilling tube, or just for manufacturing in each country.
So I didn't catch that, Andrew.
Okay.
It is an accessory we can offer, but quite often we advise people that it's quite easy to make a device like this, and you don't need to have hundreds of holes. You just need to have two holes, one hole really. And this is one where hydrostatic submersible transmitters are used to, for safety reasons, to make an alarm if the water level is rising. So the water table obviously is the level at which water is below the surface. So in some cases, it's important to measure this table water level to avoid flooding further down the system somewhere. So in this case, you have a lake, which is there's been a lot of rain. The lake is filling up, and eventually the land, the water level below ground will start to rise, and a lot of our customers use this. They drill a hole into the ground, a borehole, and then they lower a transmitter into that hole, and they keep a close eye on what the level is. And when it reaches a certain level, after lots of rainfall, they predetermine that level. They know what that level should be, and then they know they need to take some action. So maybe they need to release some water from the lake carefully to avoid flooding. So it's control of river levels, lake levels, to ensure, to avoid disasters, really. So that's quite popular in the United States. That's quite popular for us. And this is what happens. So we have a PR3442, which is a very slim, small diameter transmitter that goes into the hole, and the customer knows what the acceptable water table level is, and they will set an alarm level, and that will transmit by whatever method to a local station, and an alarm or sound when it reaches a certain level. There was a sensor coming in. So this is a slimline version of the PR3441. And typically, the 3441 is used for 1 meter, 2 meter, 10 meter, very popular. This is used for the deeper holes, the higher levels. Oh. And that's what can happen if you don't keep control. So yeah, it's used a lot by water authorities in various governments around the world. And just got a little bit about the hygienic range of transmitters that we have. The face of the hygienic transmitter, the process connection, is there are several different types, but there are certain types that are very popular. Pipe clamp or tri-clamp is the most common, and you have a completely flush membrane. So this is like the sensor the isolated sensor that I mentioned last week. It has a convoluted membrane. So stainless steel is very thin membrane, and behind here is a food grade oil or food grade liquid. And when you press here, the force is transmitted to the sensor in here. So it's what we call flush diaphragm or barrier seal. And the stainless steel surface means that there are no bug traps or bacteria traps where it's polished to a certain finish, a certain RA finish, which means that fine molecules of bacteria cannot stay on the surface. They won't lodge on the surface. And of course, periodically, when systems are cleaned, you can take the transmitter out very easily. Usually they clamp in, very simple clamp or nut, so easy to remove, and then you can clean the surface. The big concern is the cleaning process is to be very gentle. You can't use high jet pressure, or you can't use a brush or a screwdriver to clean the surface. You have to use warm water with certain chemicals that will ensure that the surface is clean but not damaged. So here's an example of installation technique. So this is the pipe clamp. So you can see it's a very simple twisting mechanism. The pressure transmitter is attached to a stainless steel ferrule, we call it, and then it's clamped. And as you tighten the clamp, the two surfaces are pulled together. And there's a seal between the two surfaces. So very, very easy to install, very simple to remove and clean. And it's always 316 stainless steel. That is the standard grade. It has molybdenum as part of as well as iron and other materials, and that makes for a very smooth surface without any cavities. Bacteria can be trapped. So as an example here, where we have a breakfast cereal manufacturer. This is very close to us. We have a big, world famous manufacturer on our doorstep, and they make cornflakes and bran flakes, and they use a lot of pressure cookers, sometimes going up to 125 degrees C, even higher for cleaning. And so we excuse me, the process would be to have a mating ferrule. So this is the mating part, and that will be attached to a tank. So you need to make a hole in the tank, at the bottom of the tank, and then weld this ferrule into the stainless steel tank like this. And then here's an example of a welded ferrule in the tank. Then you need a seal and a transmitter and a clamp. And then you can join everything together here. So you can see that the clamp has a taper. So as you tighten it, it pulls the two surfaces together. So at the moment, we do not have 3A approval, but it is something that we are working towards. So next year, I'm expecting that we'll offer a whole range of sanitary transmitters with FDA approval, 3A approval.
Perfect.
So, yeah, this one is the half-inch BSP. So this is very, very, very popular. And you can attach this into a pressure port and make a seal around the hexagon. But we also offer this, we call it a weldable ferrule. So what happens here is that when this is welded into the pipework or the tank, and you screw the transducer into the tank, you end up with a perfectly flush fit, like this. So it gives a very nice flush diaphragm, and it means that if you have viscous material, foodstuffs, all sorts really, that you don't have any buildup, you don't have any trapped materials. So we have these in stock, and we offer them if they're required. If not, we offer a drawing so that this detail can be machined into your pipe work or your tank. So we can either provide the ferrule, or we can provide a detailed drawing. Okay. I think we're getting near the end. This is an interesting application where a customer in the UK, they do lots of testing for the oil and gas, medical, any industry really, that come into contact with aggressive liquids. And they have the capability of making tests in various types of aggressive liquids or at different temperatures and under pressure. So they will lower sample pieces. It could be a piece of an aircraft structure or an oil rig or some kind of device that is going on into a nasty area, and they lower it into the bath, and then they fill the bath with the chemical and pressurize it. So this company came to me many years ago saying that they had lots of failures. The transducers they were using were corroding and dying. And they said, what can you do to help? And I said, well, you've come to the right place because we have a pressure sensor that is made from titanium. And all the parts in contact with your liquid will be titanium. And they said, that's fantastic. And over a period of probably 1 year, they replaced every transmitter they had in the facility with our GS 4200, just standard product. It was cheaper than they were already paying and has this great chemical resistance. So without any modification, this product was just ideal. As you know, it's all welded, no O-ring seal, and yeah, they do all sorts of transport. They do a lot for trains and buses, that sort of thing. Salt test, so it's perfect.
Now, for example, in our case, we had a problem with the in the water plants for the situation with the mountains at the high level for contamination. We have a specific water plants that they need or they input a lot chemicals. So for the reason the transmitters have a low shelf life, and I think that maybe we can talk about this specific material for the titanium. We have a better solution that you need to replace. So I think that is very Adrian. I think that is very important for Acueducto Bogotá. They have three plants, so for this reason, it's very important to talk about that. Okay.
Can you hear me?
Now, yes.
Yeah, sorry, it went quiet there.
Okay.
Went very quiet.
Okay.
So yeah, I mean, all sorts. I mean, myself, John, and Tom, we have lots of chemical resistance charts, and we can advise you on the best solution. Titanium is great, but sometimes there are applications that need other materials, but we can do other materials. We can make Hastelloy, Inconel, brass, bronze, you name it, we can make it. So, but a lot of our sales partners forget that the GS4200 product has that unique titanium wetted parts feature. So it may not be one of the cheaper products in the market, but it has a lot going for it, apart from reliability and accuracy. But it does have that, that benefit of being suitable for, as I say here, they do sulfur testing in crude oil, petrochem products, gases, sour gas, H2S, all sorts of very nasty chemicals, and seawater. Seawater is perfect. Anything to do with salt water is ideal, because no matter what people say, that 316 will corrode. So I think that is that presentation. I do have, if there's any particular part of that presentation you think I'd like some more information, I think I do have other presentations, but I'll make sure that I know Michaela has given you your access for the website. So if you go onto the sales partners area, there are lots of other supporting presentations that you can download. So I recommend that.
Perfect. Yes, in our case, really, for the different markets that you comment, I think that the oil and gas will be the best. I think that our mistakes was try to just offer the solution in a plants, not in the all markets. I mean, for the upstream, downstream that I comment specific for testing, for corrosion that you mentioned. I think that we need to make a better focus in oil and gas in specific this application, because I comment the last week. It's all about the plans when you have the competitors like Rosemont, like Honeywell, like ABB. This is so
Yeah.
complicated. It's so complicated because this client just thinking about the display and the hard communication, and that's all. So for this reason,
Yes.
yeah, for this reason, change the focus specific for these areas in this sector oil and gas. I think that is our plan. And it's specific that you comment, for example, in the navy or in the ship applications, really is not. We have application is just in level, because, for example, I live in Barranquilla. Barranquilla is in the coast.
Yeah.
Adrian lives more in the center in Bogota, that in these cities. And for this market that I comment here, uh, we have a biggest company, but it's just for maintenance, for spare parts, for the ships. Unfortunately, because for this reason I comment, and I ask you about the Panama, if you have a partner in Panama, because in Panama we see that we have a lot of application in this sector.
Yeah.
And
Interesting.
I think that is this is the most important, because, for example, when you comment about the water plants, really we offer, but with the solution that you comment about the hydropump, the hydro submersible, we think that the market specific for the monitoring in a networks, I mean in the river or pipe or water network solutions, you know have the problem with the people installing the device, like ultrasonic radar. Is very common, unfortunately, here in our countries, that you need make a level monitoring, and the people see the boxes, and unfortunately the people stolen this, and it is very common. So for this reason, when you comment about this application but submersible, you know the
Yeah.
the people don't see that, and is more easy for them, in the budget, try to repair. And I think that other way very important for us is that I comment about the titanic materials, because, for example, here in the coast, here in my home, I mean, we need to paint I live in a building in a 60th floor. I have a beautiful, maybe I send you a photograph about, but you see the old city, the river, the sea. But the problem is the corrosion. We need to paint. I think that's 3 or more each month, and we need to paint the old metallics things, and it's very common
Yeah.
here have this level to corrosion. And when you visit the clients in the different plants, they have suffers, just not for replace, for seals, for electronic, is for corrosion. And so for this reason, I think that is very important. So change these sales terms, and not just talking about the USB configuration, is talking about the material composition, about the titanium. I think that in the past I don't see that. I think that with this training, it's very important for us to know about in this use. So I really appreciate, Paul. I think that this is the best conclusion that we had for now. And now, yes, it's that. I don't know.
No, that sounds good. What I would say is that if I will look at what other trainings I have, and I'll send you an email. You can decide if there's anything you would like me to go through, perhaps next week. But also, if there's anything in particular that you'd like to look into more detail, let me know. But it is interesting what you say about the other brands. They are those pressure transmitters by ABB and Rosemount are a different style altogether. So we just need to find little niches for our products.
Exactly. I think within that this is my mistake in the few years with ESI, because we, the people send an email and always mention the brands, and you try to make a replace, but you lost time in this quotes. So for this reason, I think that is very specific that you comment. Have these better niches. And I have other question about the Latin American market. Also Brazil, Brazil is other. Brazil is not a Latin American market, because for the custom process is other things. But what is the best application that you see in Latin American market, with other partners, that we can replay more easily?
Yeah, sorry, the sound isn't very good actually. But you say what areas of South America do we? Was that your question? Was where in South America do you see opportunities?
Yes, because but no Brazil, because that Brazil with the custom process is other team,
Yes.
is other area. I mean, but for example, Mexico, Peru, Chile. Okay, the other countries, Argentina, have a large problem now for the dollar, but these specific countries, you see frequency applications that we can replay here in Colombia.
Yeah, I'm sure there are applications in those countries. We are not. We are happy to supply, or to supply you for other countries. We don't have any other agreements.
Okay.
For Ecuador, Peru, we have long-standing sales partners in Peru and Chile, for instance, but they are non-exclusive. It is not a problem for us. Okay. If you wanted to to go into other countries, if you mentioned Panama, Peru, any of these countries is okay. Argentina, we don't. It's really only Brazil that we have a fully established sole distributor, if you like. They are also distributors or sales partners for Suco, so we have to respect that side of things.
Yeah.
But other countries, yeah, we are interested. Anything that you have in other countries, for sure, we would be interested to hear about.
Okay. No, because for us, Paul, I explained the past for the successful. I think that is the successful business plan that we made with the other company, for the British company, for what I commented before, for the moisture sensors. We work very very good, because, for example, I told about the importance that the product, technical support, and application. When you try in these countries to talk about the sales terms, about the payment terms, it's other business, because unfortunately, end users with these companies, with these sites for the companies try to pay to 90 days, 120 days. So for this reason, I comment before, and I mentioned we our business is a supplier for instrumentation automation products. We our business is not a bank. so it's better for us when you talk with, for example, the last order that we made in Mexico. We talk with the people. We talk with the people. We stay pending about the invoice, about the all products, but you need to pay to UK. That's all, and I think that is better for us. It's all about in these terms, because our business is not just sales. Our business is a service. It's a commercial or service. You know. So for this, so for this reason, for us, I think that is the future that we want really. Try just talk that have the service, and the technical support in our area, and the and this supports in the commercial when the people make the payment. So if you want, we don't have problem with that. Contrary, we really appreciate this opportunity, but we think that is the way for have more business between with ESI, I think.
Okay, good. Yeah, well, we're open to all ideas.
Yeah.
You'll find us. We try to meet everyone's requirements. We're quite happy to listen to anything that you propose, and we'll always try and support your activities. We've got a good open approach to things. I think we're
Okay.
quite accommodating. So yeah.
Perfect. And I have other two questions. The ones is, what is the limit that we had in comment in a YouTube channel about the equipments? I mean, because we know that you use for commercial, for technical supports, but we see that in the we need the password, the username and password for see other videos. What is the limit for have a public information and a private information just for this client? Because we need our marketing plan in the next years will be make a lot videos, a lot application for reduce these terms for sales. So it's very important for us.
Okay, yeah, that sounds fine. I think what I'll do, I'll ask Michaela to get in touch with you so that you can get some dialogue going about that, and she can help with material as well. So if you leave that with me, I'll instruct Michaela to get in touch. She's more au fait with the YouTube side of things. But we welcome any ideas that you have, any efforts you make would be great.
Yes, because for us we don't have problem. We make our videos and make in our social networks, including YouTube. But my question is, we have a limit about the information, because you see the ESI YouTube channel, but the specific information that you see in your website with the partner login is too different. So for this reason, we need to know if we have a limit that show this information, or is better just make this information just for partner logins, and the other is different. For us, it's very important what is the limit that communicate the all information for us.
Okay. I'll come back to you on that one. Michaela's in tomorrow. I'll come back to you on that question.
Okay.
But we welcome any efforts you make, really. But
Perfect.
yeah,
Perfect.
come
No,
back to you on that.
perfect. And the other and the last thing is important for us, Paul. If we really appreciate, for example, the scheduling that you have for the social networks that do you work. I think that how partner is important that we share this information, but before that we see in your social networks, we can translate and we can pause at the same time that you can make. So for this reason, I think it's a propose in the future. For example, you mentioned in November we will make I don't know 10 posts at this time. It's important for us know before for replay or for share the same information. I think that is very important have this integration and not just wait because in this moment you see okay the Micaela post something okay we need to translate and we think that is better that is more synchronized.
Great. No, that sounds good. That's a good idea. I have a meeting with Michaela on Tuesday. I just looked, and I'll bring that up. I think that's a good idea that we share that in advance.
Yeah.
I have asked for her to do more with social media, to have more of a plan, because we've been a bit quiet recently. We haven't put as much attention to that as we should.
Yeah.
But that's partly because of COVID-19 and everything else. We've been focusing on other things, but yeah, I'll come back to you on that as well.
Yes, and you have a partner that can help you in make these translations. Don't pay the translation. We can make that. So for this reason, this material is for you too. For I mean for other partners like in Spain or I don't know. So we really we can work in this way. No, thanks a lot, Paul. I think that will be great these two section. I really appreciate, really appreciate. Thanks for this time.
Pleasure.
And now I think that is have this year try to close okay with this problem with the pandemic, but I think that in the future the next year will be better for all.
Yes, I think so. Yeah. Well, I'm enjoying these meetings we're having, and I think it's really positive. And yeah, I'm glad we're doing it, and I really like your positive attitude as well. That's excellent. So we need to capture that and build on it and grow it together.
Yeah.
So yeah, I'm completely on board and appreciate your comments and good intentions. Yeah, thank you.
No, you are welcome. And sorry again if sometimes the practice for the English could be but yeah it's difficult sometimes when you don't have this practice. So for this reason, sorry for trying to resolve, but okay. No, okay,
Don't
Paul.
worry, no.
Okay, Paul.
Yeah, that's fine. Yeah. Thank you again. Yeah,
No.
that's excellent.
Okay,
And we'll speak again soon.
Okay, thank you so much, Paul. See you then.
Okay.
Okay.
Take care.
Okay. Take care.
Bye, Adrian.
Bye.
Take care. Bye.
La que ha llamado no se encuentra disponible.